So what I've got is I've got a big printout of the PC board. I've got the schematic diagram as well, so I know where the components are, like R2's up there, and I know that from the schematic R2 is 1.2K, so just put that to one side. This is a DRV8825 hardware 203. We can do a full and minimal plus temperature probe or minimal, and it's all silk screened. So I've got a series of capacitors and resistors. We're going to do the small ones first. So this one here is 1.2K, and there are 3 of them required, and we're going to do this on the board. And according to that, that's R1, R2, R3. So let's just bend the components like this. R1, R2, R3. So there's R2. Just put that in there. I'll take it there. And I'll just slightly bend those like that. That holds it in place. R1. R3. And last one, R2. R2, R1. Alright, so that's good. So we've got the soldering iron nice and warm. We'll just make sure there's a bit of solder on there. And what I want to be able to do is I want to be able to heat up the base of the wire where it actually hits the PC board, just for 1 or 2 seconds. Boom, apply some solder, let it go. Apply some solder, let it go. Apply some solder, let it go. Heat it up, apply, heat it up, apply. Heat it up, apply. Now this one's not quite done, so let's just do that again. So you can see that I'm not holding the soldering iron there for too long, otherwise it'll heat up too much and damage the board. So let's just use some side cutters to whip off those wires like that. So those are those resistors, and I'll continue now with the remaining resistors and the capacitors. So we've got here the 100 UF capacitor. It's got a white side, that's the negative. So negative goes to negative. This is for C6, is it? And we just place that in like that and solder it in. Trim off the wires. The LM7808 regulator I've already got fitted with a heat sink, and so the board has got two double lines. That 2 double lines is the metal end, so that's going to go in there like that. So let's just whack that in. So what I'm going to do is I'm just going to solder one leg like that. Just check to make sure that it's all seated properly. It is. So now I'll solder up the other 2. If it wasn't correct in terms of, you know, being too far away from the board or whatever, what I could have done was just use my finger, heat up that single wire and get it right, and then solder up the other 2. So far so good. We've got one more capacitor to go, and then we'll start putting in the headers. Alright, so I'm going to leave the diode to last, and what I'm going to do now is I'm going to put in the various headers. So let's start with a 2-pin header. Oh, 2-pin header, 2-pin header. It's going to go in here like this, and there like that. So I'm going to hold it in place somehow. These are a wee bit tricky. If you've got a If you've got a PC board holder to do this, it's just as good. But I'm going to hold it with one finger. So I'm holding this pin here, so I'm going to solder the other pin. So we'll just get the solder into the right place, and I'm just going to tack that there like this. There we go. It's not quite straight up and down, so right it is now. So I'm going to solder the other pin on. There we go, and I'm going to use the same procedure for all the other pins. So we've got all the header pins in all over the place, and next step is, look, I'm going to use, that's not quite right, so let's just, it's on an angle, so I'm just going to gently, right, so that's good. So the next thing is, what I'm going to do is I'm going to use these 16 pin headers, so that I can, if I ever blow up the DRV chip, I can replace them easily. So they're going to fit in like this. Sometimes it's a bit fiddly to get all 16 pins in, sort of have to move things around a bit. There we go. It's easier than I thought. So again, basic principle: tack one, get it right, and then solder all the others. So I'm just going to bend that slightly just to hold it and try and hold it in place. Put something underneath it. Let me tack this. And I want it straight up and down, which it is, so I'll go ahead and solder all the remaining pins. So in soldering these, what I'll do is every second one I'll solder as I go through, and this prevents too much heat being applied in one place. Right, and then I'll start back at the beginning and I'll solder every second remaining one. And again, not too much solder, because we don't want to bridge. Every now and again, just drop the solder off, soldering on. We don't want to bridge any of the pins, because that'll create a short and that'll cause problems. Alright, so that's soldered. Now what I'll do is put the other header in and solder the other side. Alright, so we've got everything soldered, except for the DRV stuff at the moment. When you use the side cutters to cut the leads off, don't cut them right close to the board. Just leave a little bit of lead there, because what that does is it doesn't place any stress on the join. And the next thing is to put all of this under a microscope and just make sure that all the solder joins are fine, that none of them are actually touching any others, and there's no issues there. So all we've got left to do is mount the DRV, put the nano chip in here, and put the diode in, and then we can start testing the board. Right, I've got a 1N5401, it's a 3 amp diode. It only needs to power the board, it's not providing power to the stepper motor. And I'm going to use this 5401, same as a 5408, doesn't matter. But the leads I've found are just slightly too big to go through the hole, so don't want to drill the PC board, because that'll ruin it. So what I've cut the leads a bit short on the diode, and I'm just going to use a file just to trim down the leads a wee bit to make it fit. So we'll come back when that's done. Right, I want to mount the DRV 8825 chip. Now I've got this is a IC socket, which all in line, 16 pin, 8 on each side. But you notice it's not the right size. So what I'm going to do is I'm going to cut it in half and separate the two sides, and then mount this on the PC board, and then the DRV 8825 chip will plug into this. So that's what we're about to do. In terms of solder, I've got some solder here. It's got flux 2.00, but the diameter of it is 0.88 millimeter, and that's so if I used a thicker solder, I'd be putting too much solder on the joins. So using something like 0.8 millimeter is really good, because then when you solder the joins, you're not putting a hell of a lot of solder on and getting these big blobs. So let's fit this DRV8825 socket in. Alright, so I'm using some fairly sharp side cutters, and I'm just going to go down through the middle. Bang, that's it. And now it's a matter of putting each of these in here. It's going to be a bit fiddly. There we go. And the same principle as before. Sort of hold things in place while we tack one pin. That's right. There we go, take one pin, sort of try and get it straight up and down as best we can. Yeah, that looks good. So I'll solder up every second one. And now the other side. Right, so let me just try and sort of show you. I've got this on here, and the where I cut it's actually in the middle. So we've got the two outer edges, two lip edges, one on this side and one on this side. And what that does is make sure when we put the chip in, the chip is actually seated correctly. So that's looking quite good. So I haven't got the resettable fuse in yet, and I've put a straight jumper on the resettable fuse, and I've put a straight jumper on the on-off switch, which is they're marked on the board. And I've got a little 12 volt power jack here with a 2P header, and I soldered this on and put some heat shrink wrap, and I'll show you how to do this later. Red's actually positive, goes to the center pin here, and black's negative or ground, and it goes to the outside. So what I'll do is I'll make sure that plus lines up with red, and there it is. And sitting here I've got some 12 volts from my power supply, so if I connect this up I would expect the Arduino to light up. So there we go. So the red light on the Arduino is actually lit up, as you can see. So there's power to the board. That tests to make sure that the LM7808 regulator is actually providing 5 volts to the board, which it is. So far it's looking pretty good. I got the board assembled. I bought some 2P, the red and white wires, 2P headers. And so, for example, if I'm looking at the board and I want to wire up the sort of switches, we start with these. Push button 2, push button 1. And what they just fit on like that. And so with the switches, it doesn't matter which way it's wired. So what we're going to do is we're going to solder the switch to here and put a bit of heat shrink wrap on, and that way you'll understand sort of what we're doing. So we'll just cut some heat shrink off. This is 2mm diameter heat shrink. And we'll make sure we're soldering on this. That is good to go. So we'll just make sure that we put some solder on the existing wires. Already come soldered, but it's good to do this. And then we've got the actual switch itself. So just find some way of trying to secure this without it moving. Take a bit of solder on. Take a bit of solder on the other side. Right, so I've got the heat shrink on, and we'll just wire up the switch. With the switch, it doesn't matter which way, it's which lead goes to which. So just make sure that that's soldered on there. Right, so the switch is wired in, and so what we need to do is I've just moved the just go and burnt my thumb. Push the heat shrink right up against the actual switch itself. Get a cigarette lighter. As you can see, the heat flame, I'm about half an inch or so away, and just making sure it's not get too hot. And that's it, that's one switch done. So now it's a matter of going through doing the other switches. I've already done the power on off switch, as you can see. So go through and do those, and then we'll come back and have a look at the LEDs. So I've got a, this is a 5 volt pre-wired LED. It's already got a wired in resistor. This is green. And so what I'm going to do is, if I join this with this, of course the wires are way too long. So what I'm just going to do is I'm going to cut a bit off each, and strip some lead. Strip some lead on the other one. Now, of course, I need heat shrink on the joins, so I'll put some heat shrink on. And I need another piece of heat shrink. So let me cut a bit. Put this on here. Right, so red goes to red. And just wind those two together. And black goes to black. So, or black goes to black red. So we'll just wind those two together. Now we'll solder those. So that makes sure that the join, we'll just trim off some excess wire here, doesn't need to be that long. Oh. Alright, and then we'll just move the heat shrink over the wire, over the joint, so it's not exposed. There we go. And use the trusty cigarette lighter to apply some gentle heat to the tube, which will force it to contract and seal over the join. So there we go, that's the green LED done, and we'll go and do the other remaining LEDs. There's 2 of them left. There's a 12-volt one, which I'll use different colours so that I know which ones they are. Right, I've started wiring up the 12-volt power jack, and I need to know, I've got the meter set to resistance, I need to know which pin is ground, so that's not the one, and that one's ground, so that's the one I need to wire to. So I'll do that now. Okay, so let's just take stock of what we've got here. We've got the 12-volt in, which will go to this particular jumper here, plus to plus. We've got the 12-volt lead, which is this one, so red goes to plus. We've got the 12 volts on-off power switch, which is this one. Doesn't matter which way this goes around. So that goes in there. Alright. We've got the power on reset circuit. Jeez, I can't read the board, but I would suspect it goes here. It doesn't matter which way around this goes. I've got the blue LED. So it looks as though it goes there, so red to plus. I've got the green LED. So I believe it goes here, so plus is that way. I've got the push button switches. It doesn't matter which one's which. It doesn't matter which way around they go. So those are the push button switches. Looking good. Push button switches. Still got to do the buzzer. Still got to do the temperature probe. So the temperature probe, I've got a using a 3-pin stereo jack here, and I need a 3-pin header, which I'll get in just a second. Wire that up. I've also got to wire up the RS232 connection to a 4-pin header. So this is a 4-pin header. So this 4-pin header can go on here like this and connect up to the various pins of the stepper motor. And what I like to do, so I just like to put a little dot on the board like this and mark one end of that header, so I know that's the way it goes around. So I know that it'll go pin 2, pin 1, pin 3, pin 4. So I'll know how to wire that one up. So we've just about got it all together. We've still got the buzzer to go. Still got to wire up some of the external components like this to the temperature probe and stuff. But we're going pretty good so far. What I've got here for the LEDs is I've got some little 3mm plastic bezels, and the LED just pushes into them. So you drill a hole which fits the outside diameter, push that into the case, and then this just pushes up, so it looks nice and professional. And so we've got the buzzer here. It's got a seal on it which says plus. The plus is always the larger or longer lead, and negative is always the smaller lead. These are continuous tone, so if you put 5 volts across here, it will make a sound. And we'll just wire this up to a 2P header with heat shrink wrap, and that'll do the buzzer. Alright, got a 3-pin header here. I've got, looking at it this way, I've got VCC signal in the middle, ground on the outside, and this is going to go on the temperature probe. And I have to wire this through to the 3-pin. So the sleeve is ground, obviously. The tip there is signal, and the remaining one is VCC. So what I'm going to do is I'm going to wire this up. Got heat shrink wrap as well, and then I'll mark the connector because it's going to go that way. I want to make sure that it's orientated correctly on the board. There we go. So I'll wire that up now. Right, so there we have the temperature probe jack all wired up, and it's just a matter of now plugging that in, making sure the orientation is correct. There we go, and I've already done the buzzer. So we virtually have everything wired here now, except for the LCD and except for the RS232 stepper, which I'm going to work on next.